Hi, Nikhil.
Hi, Praveen.
Yeah, you can hear me clearly?
Yeah, no, I can hear you.
Okay. So you remember what did we do in the last class about, like, we did tree traversal?
Yes, Praveen. We had a assignment of writing in order traversal program and also pseudocode for post order.
Okay.
And also the creating a tree. One second, I don't remember the exact question.
Hello. Huh, bro? Nikhil?
Yes, Praveen.
Yeah. What about this? Others haven't done yet. So shall we do traversal only today, or shall we do dynamic programming?
Anything, Praveen? I like.
Okay, then let's. I think we should do more of tree traversal, uh, rather than, because we haven't covered a lot of traversals.
Okay.
So can you repeat the assignment? What the assignment was?
Yeah, one was program for in-order traversal.
Okay.
Then is pseudocode for post-order traversal.
Okay. And
Next was pseudocode to determine a tree using post-order and in-order traversal.
okay. Did you submit anything
Yes, very nice. Submitted in-order traversal program.
in the email? Nah?
Yes, yes.
Okay. Hi, Santosh.
Hi, Praveen.
Yeah. So I think, what is Sukune? Is he joining or not? Okay, so I have here the code which has been written by Santosh, and I think this is the implementation of the tree node, and this is the code for post order without recursion. Correct, Santosh?
Yes, yes, Praveen. There is a
This
small
is the only
correction
code
in the
you have
else
submitted?
condition.
Yeah, come
Sorry?
again. There were three assignments. Did you try all three or just this one?
Oh, this one.
Okay. Let me open Nikhil's code as well. Iterative in order. Oh, nice. You have done iterative in order only. Okay. We'll go through this one. So we'll start with iterative post order, which Santosh has submitted, and then we'll do for iterative in order, which Nikhil has submitted. Anything else? Anyone else has submitted any other code? नहीं ना? ठीक है. Okay. So this is the implementation of the tree node, which is good enough. String, we have data left and right node. We have left children, right children, and there's a check for is leaf using if left is null. Return if left is equal to null, and then this also okay. That's a very compact definition of a leaf. But anyway, this is good. Okay, so we have this post order traversal without recursion, which and Santosh is trying to use a stack here. What he does. So Santosh, can you explain this code to Nikhil? Like what you're doing
Yes,
here?
yes, yes.
Yeah. Yeah.
So I have created a stack here, and the first root element I'm pushing into the stack.
Mm-hmm.
So once I have pushed and I'm checking if the stack is not empty, then I'm searching the topmost element in the stack.
Okay.
So once I got the element, that I'm checking is that node is leaf or not by checking is there left or right child elements are there or not.
Mm-hmm.
If that is the leaf element, then I'm popping up from the stack and printing the data of that node. In the else condition, actually in the else condition, there is a small correction. Actually, I have to do the rightmost element into the stack first and then leftmost element. There is a correction required.
Santosh, I think this is a pre-order, right?
No, post order.
Okay.
Because each and every node from the rightmost element, first we are pushing into the stack and we are traversing through left.
So did we do pre-order without recursion in the previous class?
Yes, we did, Praveen.
We had pseudo.
So we use Q for pre-order. We use Q, if I remember. Yes.
No, we used stack on. We used stack for pre-order.
Okay, let me go back. Okay, this is iterative pre-order. Here also we used a stack only.
Yeah.
Okay. So we pushed an element into the stack, and while this is not empty, keep on popping. And every time you pop, like take the topmost element. Every time you take the topmost element, just push the left element, push the right one first, and then push the left one first. So this was the very simple implementation for iterative pre-order. Now, if I just see what you're doing here. So you push the node, and similarly, while it is not empty, you just check if the current is leaf, then you print that, you pop it and then print. Otherwise, if current dot left is not null,
In the else condition, Praveen, the last if condition should be first, because every right element we have to first push in the stack. Yes.
okay.
Yes.
Will this work?
Yes.
Let me think. Please give it again. Nikhil, you can also confirm whether this work or not.
Okay, bro.
Yeah, okay.
Praveen, I just have pinged the pre-order also in the chat.
Pre-order as well. This is the what we have implemented, na?
Yes, yes.
Yeah. Okay.
Yes, Praveen, I think it will work. I think.
Okay. So if current is not leaf, let's try to draw a tree on and then try to do.
Yeah.
When I was thinking about this solution, Praveen, I was thinking of using two stacks.
Two stacks.
Yes, like one to push the left elements and one to push the right elements, and then pop.
There's noise coming from your side. Okay.
Oh,
Okay. So if we
Mhm.
start this code, try to do the same code if we run this on this tree, we have to first push one into our stack. So let's draw a stack as well. So this is a stack. So we have pushed our three here, sorry, one here first, and then we do it while this is not empty. Is the current equal to no rupee? Is this a leaf? No, it's not a leaf. So it will go in the left part, and it will check if it has both. If the left is there, then push right. First push three, and then push three, one, and then you push three, and then you push two also. Okay. So now we just take two again, and then we push our two is not leaf, hence we let them go nowhere, and then we push our four, five and four. Five. Do we pop? Do we pop two somewhere? This is a peak,
Yes.
not pop. Is this peak or pop?
Peak.
Not pop, no? Okay, so we are
No,
not popping.
inside these leaf condition, we are popping up
Two
before
here.
printing.
First you push five, and then you push four. Now what we do is we take it out and we check this is the leaf, hence we pop it out also as well. So four is printed and popped. Okay, and then we again try, and then we again go. Five is also printed and popped. This looks good till now. Now we take two. When we take two, we check the leaf or is not leaf.
It's a leaf, Praveen. Inside this else condition, we are making the right and left is null before pushing, after pushing.
Okay, yeah, here we are making it left and right. Okay, yeah,
Yes.
yeah, that's what I missed. So we have done this whenever we push a node. If it is leaf, then the pop. Otherwise, just make it left and right null, so that the second time we're visiting it, we will pop only. So okay, this is leaf now for now. Hence This will also be out. Now for 3. When we had pushed 3, no wait. Now what? Now 3 is there. 3 is not yet. We just pushed it, but we do not make it. So okay. So it will try to push. 4, 5, 2, 7 and 6. It will push 7. And then push 6 and make leaf equal to null. Sorry. Okay. 6 and 7 is pushed correct. Now again pop 6 because a leaf, 7 because leaf, 3 which has been made a leaf. Now find 1. Okay, this looks, and this is the correct post order.
Yes.
Yeah. Okay. So post order is 1 and 4 and 5 and 2, 6 and 7 and 3 and 1. Yeah, correct. Okay. So yes, Nikhil, you're saying you would like to use 2 stacks.
Yes, Praveen. I thought first when I was thinking about the solution, I thought of using 2 stacks. One to like traverse the tree and push all the left elements. So left element and root goes there, and 1 stack for pushing the right element.
1 stack for pushing.
The right element.
Can you try to write a little bit of code and then we discuss that as well?
Okay.
So let's try to write collectively then. So you want to use 2 stacks and where will left for my mind. Just a minute. Yes.
क्या ट्यूशन पढ़ाते रहते हो भाई जब देखो
Yes. Sorry, I had to go. Yeah. So we are trying to implement our post order, iterative post order, and that too with 2 stacks, which seems as a little bit simpler solution might be, but this is the best solution. What he has given, what Santosh has given is one of the best. But still, if you want, we can try to write this solution as well. Post. Sugandha, you there now?
Yeah, I'm there.
Nice. Okay. So we are doing post order traversal without recursion. We have seen one solution given by Santosh, which we're using a stack. Now we are trying to use 2 stacks. Okay. We want to use stacks. Let's use stack 1. Yes, Nikhil. So we have this now. What do we need to do? Nikhil?
Yes, Praveen. I think we are pushing. Yeah, we'll push and then we'll iterate till the left node, like how we did.
Right. Okay. So what we will do is again we'll till the stack 1 is empty. We'll try to is empty. Again, noise is coming from your side. Yes. Anyone has anything in their mind?
Praveen, won't you make that element, the next element as element dot left, so that
No. So if we so we have to use other one as well. Like this is the normal traversal we can do. Stack. No. So push. How can we use our second stack as well to do the? So what? Suppose we just do this thing. Whatever I've written without using stack 1. What will happen at the end? Whatever will go into our stack, what that will look like, that will the order, that order will be something similar to our pre-order, but we don't want pre-order first of all.
yes,
It's not a pre-order. This is not even pre-order, because in pre-order we push the left right first and then we put the left, but here we pushing left only first. But still, without using stack, this is what we can do. Without using stack 2, this is what we can do. Just while this is empty, keep on popping and then push the left and push the right. Okay, this is what we can do. Now how can we use our second stack to just store the proper order? So what is happening is we are going top to down in the tree, and we are visiting the left and then visiting the right. Okay. Now in this order, if we use stack 2 and store, because we are doing something opposite to what we want. If you see this clearly, try to analyze this. We are popping one element and pushing the left and right into the into our tree. And if you try to analyze, what is happening is we are this order of popping. Let's see how we are popping one by one. This order of popping is exactly opposite of post order traversal. So while popping, if you simply do one thing, the stack 2 dot push this element. So now, if you see, just by adding one line of using a stack, we have stored the opposite of what we wanted in our stack 2, and hence while we can easily get our pop. Do you get this point? So this
Yeah,
single
reverse
line.
Get it.
Yes.
So we can now reverse it and get the actual list.
Yes, we cannot simply just pop it all the elements one by one from the stack 2, and we'll get our post order. So what is the trick here is, with one stack we can simply do only one order. Like we can either do with pre-order, and this is similar to pre-order, not exactly pre-order, but similar to pre-order. But so we can write this. This is the only code we can write using one stack. We can't do anything else apart from this. I mean, obviously the code which was submitted by Santosh is something we can do, but very simple implementation is just pop and then so that just push the element, keep on popping until this is empty, and every time you pop, push the left and right child. That's it. I haven't written edge condition here, like if null or not. All those checks has to be there, by the way. All these things has to be there. So you can take care of this. Yes. So after we done this, what we analyzed was the order in which we are popping. Every time we are popping element is exactly the reverse of our post order. Hence, the moment. By the way, this is also one of the key things when you think whether you use a stack or not is somewhere when you want the reverse of something that is very helpful. So suppose I give you a question called reverse a linked list. Okay, reverse a linked list. So that although we have done this reverse a linked list and we did not use any stack, but if you simply think, okay, what if I use a stack? I just visit each node once and keep on pushing into my stack. So while pushing, I have pushed every element in the stack, and now if I pop one by one, I'll get the reverse. So this is one way to think. Sometime whenever we want kind of reverse order or something, we can give a thought to stack sometime. So here also, what we observed with this, there was this. So we were inside popping element one by one in the reverse of what we wanted. Hence, we use another stack to store the order, and then we know if we try to pop from this stack now, we'll get our what we wanted. Hence, simply one more while loop here. While stack 2 is empty, is not empty. Here also not empty. Stack 2 dot pop. Correct? I mean, you can obviously push print as well. Okay, everyone.
Yes, Praveen.
Yeah. So we have done our pre-order in previous class, post-order in this class. Now, only thing remaining is we can do our in-order. Okay. So this is the code of in-order submitted by Nikhil. Yes.
In WhatsApp group, I had sent an pre-order and in-order iterative. I'm not sure if it's the solution.
Just a minute. Okay, you sent screenshots.
Yeah.
It will be difficult to discuss. Okay. Yeah. So let's take some time to analyze what is happening here. In order, so we have to use a stack again, and then we push the current node. If like we keep on pushing the node, current not equal to null, s dot push current node, and then current equal to current node. So we keep on doing until we have pushed all the elements. So like we go to the leaf node one by one, and the moment we reach the leaf node in the left side, we do if stack is not empty, then pop that element, and then current equal to current dot write, and then we do the same thing again completely. Okay. Just a minute. Let me draw for you people. So apart from Nikhil, other people, do you understand the code? What is she trying to do in order?
No problem.
Okay, let me just draw this for you first. Nikhil, can you explain what are you doing here?
Yeah, sure. So I'm traversing, and then first time I'm pushing the current node, and then I'm making the current node left, and then otherwise what I'm doing, I'm taking the first element in the stack, I'm popping it, and I'm making it right. Then I'm again doing that again and again, so that I can go up the tree.
Let me explain. So if you see this code, while current node is not equal to null, like this is bigger loop, the external while value, there's some variable which is stored. This is a bigger loop. Okay. In this loop, what you're doing, while this is true, keep on doing it. And what do you do? So keep on going to left. This is the internal code. Like if it is not null, okay, if current node is not null, keep on doing left and push that into a stack. Let me draw a stack as well. We have this stack here. So he just pushes this element and then this element and this 4 into the stack. So keep on doing this until this is not null. The moment it's null, you try to and obviously stack has to be full. And the moment this is null, you just pop it, and after popping, you push the right node out, because left node to push ho chuka hoga. Okay, left node to push ho chuka hoga. The moment you reach a leftmost leftmost child, you pop that out and push the right child. So this is here we push the right child. Now, if you see this and this, all three would be there in the stack. This would have come out of stack, and if there was something here, that would have gone into the stack. If there was something here, that would have also gone into it. Now we'll do everything. We'll do same thing, exactly same thing, whatever we are doing for this complete subtree here from here. Do you understand? So what we're doing is we're pushing the left node. Current node is not null. As dot push current node. Keep on doing this until there is no left child. The moment we have reached the leftmost child, we will pop that out. So this will be popped out. So suppose let me write some number here. 1, 2. Yes. So what we do is we push 1, 2, 1, 2, 3, and 4. Now 4 is the leftmost child with no left children. Hence, we will not go into this loop. If current node is not equal to current equal to, they won't be left. We will not go here. We'll go here. We'll pop it first. So we'll pop 4 first, and then we will try to insert the right child of this. So 4 has been popped, and while popping we are printing also. So whenever we pop, that is the time when we print. That is the time when we print our value, which is hence is pre-order. So let me just delete 4. So 4
But
has
in
been.
else condition also won't get execute, no?
What this else?
Yes.
Why not? So if current node is not equal to null, so 4 is here, and this had called when 4 was pushed. At that point of time, it was called current was equal to current dot net. There's nothing on the left. Okay. So it would go here. It will say it's not null. Hence, it will go in this. And now stack is not empty, which is with normal case. So we pop 4 first. So we have popped 4. 4 has been popped. Now 4 has been popped, and just a minute.
Okay.
Yeah. So now 4 is popped, and we will print also. 4 has been printed. Now we just what do we do is we make current equal to current dot right. Okay. Now 6 will become our new node where we're going to work, and this will repeat this complete thing for our complete subtree on this side after 6 years. So what we see, the 4 has been printed, and we'll do this completely for this right child if right was there, and hence suppose 6 was the only thing there, and hence this will be current equal to current dot node. We push the current node. We push 6 as well. 6 is also pushed, and then we go ahead. 6 has no child, neither on the left nor on the right. It will be pushed, popped again. Six is pushed here now, and since this has current equal to current dot right in this time, so there won't be any left. Hence, we won't go on deeper. It won't have any right also. So it will also become null. So current equal to current node dot right, this will also be null. Hence, it will come out of this, and then it won't go inside because stack not empty. So it will come here, and then it will check it's not null. It's not null. So current node is there's nothing on the right side. Hence, this is not null. This is null. So it will come again in here and it will try to pop. 4 was already popped. It will try to pop here 3 now. So 3 has been popped, and 3 has a child, right child, left ho chuka tha, right child. 3 it will push 5 now. So now a little bit things are clear. What is happening is we are going to the leftmost child of the whichever is our current node. Okay, whichever is our current node. From there, what we do? We just go to our leftmost child till we reach the leaf node, and not leaf node, but till we reach the leftmost node of that. While doing left. If it is found, then keep on going left. If left not found, then pop it first, and then push the right child, and again keep on doing the same thing. So this will give our in-order traversal. Any question here? Anything which is unclear? Santosh? Someone is left. Santosh left. Sukanya?
Yes.
Is this clear? The code which has been submitted by Nikhil?
Yes, it's okay.
Okay. Okay then. We'll move ahead to our new. One question was there on determining the tree given the post and in-order traversal. I think no one has tried that.
No.
Okay. So I'll have to give that as assignment again. Let's discuss then. Let's just discuss. Okay. If we're not solving, at least let's discuss. So given the post order, first I will draw the tree. Okay, so what will be the post order? Who can tell me? Post order. Nikhil.
4, 1, 3.
1, 4, 3.
1, 4, 3. Is it 7, 8, 1 or 8, 7, 8, 1?
7, 8, 10. That is 10, not 1. Okay.
Okay. 5.
5. Yeah, this is a post order. And what is the in order?
1, 3, 4, 5, 7, 8, 10.
Now, given this post and in, can we determine the tree?
Yes.
Okay.
You
Yes.
can understand that 5 from post order that 5 is the root.
You can understand from the post order 5 is a root. Nice. So you will draw the.
In order, we can understand that the left side of 5 will be left subtree and the right side of 5 will be right subtree.
Nice. So with 5 we have our left side, as 1, 3, 4 will be on the left subtree, and
But
7,
3
8.
should be the 3 should be the root from the as per the post order. And in the other part,
So determining. So now that we have determined that okay, 5 is a root, and everything on the left is the left subtree, and everything on the right is the right subtree. Now we are left with 1, 3, 4. How do we find that? What is this index here in our
from post order we get it 3 and 1 in the left, 4 in the right.
Yes. So 7, 8, 10. Okay, what we do is we have our left 1, 3, 4 and right 7, 8, 10. So we find the index of 7 where the 7 is in here. From 7 till last is a post order for right, and we find from 1 till the last, 1 till before that is the left part. Yes. Yes. So it is almost similar to our pre-order and in-order. If you want, you can write the code and then submit also. We'll move ahead. Okay.
Okay.
Okay, Nikhil.
Yes, okay, Praveen, sure.
Yeah. Let me just ping why is not there. What happened to him? Okay. So we'll do more tree traversals today. Then next class we'll do about dynamic programming. So I wanted to start time today only, but let's do more questions, more practice on tree, because that is lots of questions will be asked on trees. So you should be very much familiar with how to write code on trees. Okay, so we'll cover this tree first. So just people start. You have to implement suppose level order traversal. Think and get back in 2 minutes. What we'll do? Don't write the code. Just think what to do, and then I ask you to write the code. Question clear? What do you mean by level order traversal?
Yes, Praveen.
Yeah. So go ahead and think. How will you implement a level order traversal?
Praveen, can I say something?
Yeah.
So in level order traversal, we go for the height. So we push nodes with respect to height. So what we'll do is for each level. So for say height is 1, height is 2, height is 3. We'll just keep pushing the nodes. So first we'll push for height is 1, we'll push 1. Then for height is 2, we'll push 2 and 3. For height is 3, we'll put like 4, 5, 6, 7, like that.
Okay. Okay. So level order traversal. This is 1, 2, 3, 4, 5, 6, 7, something like this. Okay. This is what level order traversal means. And you're saying that we'll do for all the heights. So for height, height equal to let me write in Java only. Int height Yes, this is what we'll do. Nikhil.
Yes, Praveen.
What we'll do in with each height? What we'll do?
We'll 1 sec.
Is this what I'm trying to say? Sukanya? So just forget
Yes.
about this.
I'm not sure because you are just printing all the nodes at the same height. But in which order we are printing them?
Yeah. So let's just forget this code and just talk about the print all nodes at a height h at some height. How can you implement that? Given a height, I just want to print all the nodes. How will you print? Can someone write this code? So what this says, if I if I call this print all nodes at height 2, then should print 2 and 3. Let me draw a little bigger tree. Yes. So if we call this print nodes at height 3, what will that return? What is that should return? 4, 5, 6, 7.
Okay.
Is this correct? Can
Yes.
someone tell me how to write this code? Yeah, this is what we want to do. How will you write the code? Just write the code for this part. If you can write code, then we can use that for our level order traversal.
I'm not understanding it. If you are doing print all nodes at 2, then you are printing 2 and 3. Then how come when you are doing print at 3, you are doing its children?
You're doing what?
At 2, you are doing whatever was there in level with 2. But at 3,
Yes.
you are doing whatever is there below 3, below the level of 3.
No, 4, 5, 6, 7. Is that height 3 na? So height of this node is 1. Height of these two nodes are both of them height. What is the height of 2 and 3? Height of 2 and 3 is 2. Height of 4 and 5 and 6 and 7, all the height of these nodes are.
Okay, got it.
Right? Yeah. So now you have to implement this code. Just try to do it fast. How will you implement this code? Print all the nodes at a given height. How will you implement that? And this is the order also. This is correct order. Okay, this is how we want to order. I mean, it's not like you just print 5, 7, 8, 6, 4. We have to print in this order only. Print all the nodes at a given height in the from left to right order. Okay? Write this code first. I'll be back in 1 minute. Yes, Santosh.
Yes, Praveen.
Yeah. So we are doing right now. What you are doing is we are doing level order traversal. We are traversing a tree in level wise. So first, if you see this tree, so this is the order we want. 1, 2, 3, 4, 5, 6, 7. This is the order we want. Okay, we have missed something. We have 13, 11, and 2 also in this order. So this is the level order traversal of this tree. So we are trying to write the code for this, and this is a kind of pseudo code. How we do is for level order traversal we go to each height and print the nodes at that height. This is one of the solution given by Nikhil. That you go to each height one by one, height 0 and 1. Like okay, let's call it height 1 only, not 0. So what is the height of this root node? 1. Height of 2 and 3 is 2. Height of 4 and 5 and 6 and 7 is 3. So do for each height equal to 1 to height less than equal to height. Okay. Now for each height, what you do is you just print the nodes at that height. And this is a like good working solution. Might not be the best, but this is one working solution. Can we? No, if we can implement this, which is what they are also implementing. Print all the nodes at a given height. Give me 1 second again. Yes. So if we can print all the nodes at this height, if you can implement this, then we'll be able to do our level order also easily. So that's the task. Try to write the code for this. Print all nodes at a height. So given if you pass 2, it will print 2 and 3. If you pass 3, it will print 4, 5, 6, 7. Okay. So try to write this code. Santosh, any question?
Yes, I got.
Yeah, write the code. Yes, anyone? No? Okay, I see codes here. Santosh, Nikhil. Okay, so we'll first go through the code given by Nikhil only. Okay, so Nikhil, what is the base condition?
Praveen, even there is after that print at current left, we have to put current right also. And
You're
if
not audible.
height is, we are just printing that node, that current node. We are the root node. Like the current node dot data. If height is 1, we are printing current node dot data. Yes. Root dot data.
Okay. Otherwise, called recursively on the height -1.
And then we have to do also for right.
Okay. Sukanya, Santosh, do you think this is okay?
Not sure, but I thought this can.
What? Come again?
Not sure, but this is what came to my mind.
Okay, just a minute. So let's try to call this for this method for our root with 2. Okay. So what we call we want to print all the nodes at height 2, and with what height 2? Height 2 is 2 and 3. Okay. So we call this on the we start from the 1 and 1 comma 2, like root 1 root node which is 1, and then we call with the value of 2, height 2. This is height not equal to 1, hence we'll call for recursively for left subchild, that is 2 again with a height of 1, and 3 again with a height of 1. Okay, now this is height equal to 1, hence we'll just print 2, and this is also height equal to just 1, hence we'll print 3. Okay, then I think this is okay. Okay, this code is if you are at the height where you want to print. Okay, if height equal to 1, we start from big and we keep decreasing it, and the moment we reach height equal to 1, we just print it. This is a good code. Santosh, do you understand this code?
Yes, Praveen.
Yeah, nice. So Sukanya, whatever you have written, push left child and left dot left, right dot right, right dot left and right dot right. We don't need to use any stack and all. This can be done without stack. Okay, Sukanya.
Okay.
Yeah. So now we have been given this. We have this print all nodes at height. We can use this. We have whatever we have done here also. So we have used the same code, whichever method we have implemented, to print the node at that height, and we're doing for all the heights. Hence, at the end, what we'll get is our level of traversal. Okay, this is clear.
Yes.
But what is the time complexity? Sorry. What is the time complexity of this solution? What right now?
Order of n. N is
Order of?
number of n.
And where n is the number of nodes.
Yes.
Nikhil, what is the time complexity? Sukanya?
It is the time of height of the tree, Praveen. 1 sec.
How you guys are trying to calculate that? I don't understand.
Here we have 2 times We are saying 3 times. One at the root, at the left and the right.
Yes. So start from this main method. What are you doing? So how many times this loop will run?
3 times. No, if height is 1, root of data, and if height greater than 1, 2 times.
No, I'm asking what this loop. First of all, just tell me this. How many times this loop will run? Just this loop will be height times it will, because we're going from 1 to height. This is number of times is height times, okay, whatever the height of tree, and in each loop what you're doing is printing all the nodes from at that height. So just talk about the complexity of this method now. Okay, what is the complexity of this method? Only one time call, like, okay, I call it for height some x, then what is the complexity of this method? What is the time complexity of this method?
Order of 1. Yeah, just 1 sec. No.
This method only print node. So given a tree in which there are n nodes, okay, given a tree in which there are n nodes, what is the complexity of printing all the node at given height? This is a method. How will you print?
This is the order of n, Praveen. We have to go to
the
the
number of nodes.
Correct.
Number
so this
of
is
nodes.
order. Yeah. So worst case, like for height equal to last height, the maximum height, this will visit all the nodes. This will visit all the nodes. Okay. To print the last level, the height level nodes, we have to visit all the nodes before that. And for the last height, for biggest height, we have to print all of them. So hence, worst case, it will be order of n, where n is the number of nodes. Okay. So this order n is getting called number of height times. Height is assuming log n. So what is the final complexity?
n log n.
And why it was so difficult for you guys to not able to determine this? This should not be tough for you people. Okay, you should be able to just see the loop first. Simple. First सबसे पहले loop देखेंगे ना. The first time we see the loop, we determine, okay, how many times the loop will run, and we can easily see that we're incrementing height one by one, and we're going for total number of height times. Hence, it will be order of log n, because the height is equal to log n. So first part is clear. In every loop, what do? We print all the nodes, and what is the complexity of this part? This part we can try to think and end up saying, okay, it's order of n. Hence, it is n log n. Clear? This is n log n.
Yeah.
Anyone? Okay, everyone get this?
Yes.
Yeah, nice. So now we want to improve upon this. Can we do it better than this? Can we do better than this?
Yes, is it possible? We have to mark already visited node.
Try to think of some data structure. Using some other data structure. Can we use something to maintain the order and all?
If we put each of them in the stack.
Word come again?
If we put these nodes in a stack.
Okay.
And pop only the children and not the root.
I can hear noises. Please mute yourself.
We can do it using Q also.
Okay.
If we push them, insert them as in pre-order version. 1, 2, 3, 4, 5, 6, 7. Then from the front we will get.
Just try to write. Yeah, yes. Can you almost write? Try to write whatever you're saying. Others, you also try. So can you try to write whatever you say, okay? And try to write a little bit readable code so that I can understand. Don't just write randomly, okay? Try to write a little bit readable code. You're correct, by the way. Your approach is correct. Yes, Santosh, Nikhil, you also writing it?
I'm thinking, Praveen.
Okay. Sugana, you know about queues? What are the methods in queues?
Yes, insertion, deletion.
Yes, so we have q.nq and dq. So try to. So use those methods, na?
Okay.
Yeah. Okay. Is there anything you people written, or shall I go ahead?
2 minutes, Praveen.
Okay. Okay. So we have a code here by Santosh. Santosh, this is what you have implemented for what? Level order, or just print all nodes? Santosh?
Level order.
Yeah. Okay. So you have your using a stack.
Mm-hmm.
Okay. I don't know how complex it's going to be. I don't know if you have implemented it correctly or not. But as Kanay suggested, queue would be a better option. What do we want is we want level order. We want this, and then 2, 3, and then 4, 5, 6, 7, and then 13, 11, 12. So, Sugana, you haven't yet submitted? Okay. Let me then write the correct code first. Okay, go ahead and take your time. We'll discuss. Then I'll discuss his code. Then you take your time and write the code. Yeah. So what we're doing, we're initializing a stack, we're pushing the root node and then marking visitor true, and then s.o.p. What is this s.o.p?
Just printing the data.
Okay, print the data. Okay, and then while this is not empty, take the topmost, and then if node is not equal to null, it won't be null because you have popped it. It won't be null, but he can still check. This is not empty. This will never be null. This is not empty. This is not, so we don't need this case. If child is not equal to null, what is child not equal? Child will always be null.
The child inside we are getting the node inside the if condition. Because if we are not visited, then we are getting that child.
But this node will never be executed by the logic. So hence,
No, just remove the type of first if condition. Actually, that is not required.
Okay.
Yes.
If node is not visited, then child is equal to node. Okay, if child is not null, then child visited equal to true, and print child and push child. Else, oh. So we have a one post, and then one is on the top, and we take one. Left is node not visited, hence child equal to node. Child is equal to 1, and then since child is equal to 1, we'll mark 1 as visited, and then we print 1. We are printing 1 here, we are printing 1 once again here. Okay.
No, Praveen. First we have marked the root already has visited, and
oh, we have marked visited, so
yes.
we have marked visited, hence will not. It will not visited, but it won't go here, hence it will just pop it out. But next time it will just pop it out. But we didn't push anything then. If we had marked it null, visited, and printed that, and then we came inside, it was visited. It won't go here. It will go here, and then inside this, okay, it won't even go here because it's not null. This is null, and it will just pop it out. It won't do anything else. This is not work. Let's give it a thought. It won't work. Okay, Suganya.
Yes.
Anything you have? It's a simple code. I don't know why it takes so much time. When you know it's going to use, we're going to use a queue. It's very simple. It is as simple as your pre-order code. Okay, you have something here. Okay, so you have this level order. Rare front queue node while temp. Print the data, and then if left is equals to, if left is present, and that is going to enqueue that, otherwise just dequeue. That's it. So looks like you are again very much on the correct path only. I don't know why you have written this, but you don't have to initialize this rare and front and all. Simply enqueue. You have your queue of nodes. Simply do queue.enqueue and enqueue what temp dot left. So then you should be aware of these methods. You should not be writing something not needed. But by the way, you're correct what you're doing. Just queue. We have read about this. We have read about enqueue and dequeue and all. Okay. So this condition is a little bit not so correct, or it is correct. We are dequeue, and hence once we have everything is over, this is correct. Okay. Yeah, people, do you see this? This is seems to be correct now. I'll just write a better one. Nikhil,
Praveen, now I understood it. Yes, this is.
Santosh,
Yes, Praveen.
nice. Only one line is missing. That we start with q dot in q
You of root.
and then only. Right, Suganya?
Yes.
Your code only, but little bit modified. With otherwise, what will happen? You although you solve the problem, you'll be getting your marks deducted in the code. Like you don't know about Q and all little bit. I mean, although you know, but you haven't written what is the simplest part of the code. Okay, that will take some marks away. But yes, you thought correct. We'll use a Q and we'll try to push every element and let's push the left NQ and left and right, and then DQ the head node, the front node. Correct. Now, next question. Okay, we'll move to next question.
Yes.
The same level order, but reverse level order. Reverse level order. So what does this mean? We want 13, 11, 12. Then we want 4, 5, 6, 7. Then we want 2, 3, and then we want 1. Can we do it?
So yeah, Praveen, we will start from height and go to 1, right? So it is the same thing, like meaning we'll start while printing only. We'll start from height is n and then go back to 1. I mean,
I don't understand.
Like here we are printing for height equal to 1, and in reverse level order traversal, we will begin with printing from height equal to n. Means the last
Yes.
height.
Yes. So that solution which we gave first, that will work.
oh
here.
yes, yeah,
Yes, this
that
will
same
work.
thing I was saying.
Yes, this will work here. Where is this? We start from height. Yes. What about without this? Like I want to. What is complexity again? The complexity will be. Time complexity will be.
Same thing, that n log n.
And again, now we want to do it better. So how will you do now?
If we just reverse the list which we obtained from Q,
Yes.
Praveen, whatever the elements we have popped from the cube, we have to store in stack. Then we can print that values and it will be reverse order, I guess.
Okay. So I'm happy that you people thought that since we want to reverse, we'll stop.
We can-
Store. Yeah, we'll store into
We can
the
use two queues.
2 Qs.
Oh no.
I'll come to that. Wait. So as Santosh suggested, and Suganya also, ki what in this level order which we implemented using Q, we want the reverse of that. Okay. We want 1, 2, 3, 4, and now we want reverse. But you are correct that if we want reverse, but it's not exactly reverse. Okay, it's not exactly reverse. The level order was. 1, 2, 3. This is not exactly reverse. The exact reverse of this will be 12, 11, 13, 7, 6, 5, 4.
It's the reverse at each height.
Okay, let me just join this for you. This was the order, level order. Now the reverse of this is not 13, 11, 12, but the reverse of this is simple. This 12, 11, 13, 7, 6, 5, 4, 3, 2, 1. But we don't want that. We don't want this. This is slightly different reverse. Reverse at each height. I mean, we want the same at each height, but there's a reverse height. Okay. Do you see this? This is not the. So if we use a stack and while popping, while dequeuing, if you simply as you were saying, what I'll do is I'll take a stack as well. I'll take a stack. And then you're saying that you'll do s dot push. And then after we're done with this, we'll just try to run one more
Write
while
one
loop.
more while loop and print and pop it.
So what this will do, if you write this, what this will do, this will give us this. Correct. I understand this will give us this. Okay, but we don't want that. We want something different. You understand the difference between what we want and what we're getting?
Yes.
Yeah. So how will you do this? Okay. So take this as assignment. I'll give you more assignment now, and then we're done with the three questions. If we have done B, S, T, and is height balance, then we're done with all the three things. We start with dynamic programming in the next class. That will take 2 classes, and then we'll cover heap and graph. So that will be like total of data structures. Apart from that, okay. So I want to move to now algorithms. We have covered lots of data, not all of them, but lots of them. So what else is remaining? The important ones, the bigger ones are remaining: graph, heap, and then a little bit of try and suffix tree if we have done or not, I don't remember. So this thing is not so important, but yeah, we'll do this. And then we'll talk about algorithms. We'll take one of them is DP for sure next class, and then we'll talk about other backtracking and all. Backtracking, and then we'll talk about divide and conquer simple ones. So we'll take some standard algorithms, but before that we'll cover our graph, heaps, and try. This is the only data set remaining now. We have covered all of them. We have covered array, linked list, single linked list, double linked list, queues, stacks, and trees. And in the trees we have covered simple tree, simple binary tree. And then we have done that methods of insert, delete. We haven't yet talked about exact insertion into a tree. I mean, that was very simple, but we haven't talked about few more trees. If you want, I can go deeper into those trees like AVL and red black tree. So these trees we won't be doing problems, but we'll at least we'll just cover the how to insert into a AVL and red black, how to delete from a AVL and red black, how to search into a AVL and red black. That thing we'll cover, okay? So yeah, that's about in a few next classes. I'll send you what order, but these are things we'll cover mostly. For today's, this question is one of the assignment, reverse level. So try to do all these traversals. How will you gain from this is now given any question in about travel, because there are lots of questions in travels. We have just done pre, post, in, and then level order and reverse level order. They can be zigzag, they can be height order, they can be horizontal traversal, vertical order. So there are a few more traversals, and I want you to understand trees and stacks and queues so much deeper in this implementation that any order given you can think right now. Okay, we have to go in this order. So I think if I use a stack, I'll go. I can. So the simple way to traverse is root dot left, root dot right. Okay, that is what we can do easily. Root dot left, root dot right. Again, recursively call. This is simple. Now, while doing this thing only, root dot left and root dot left, what else can we use? What else I can store my data so that the final order which I want I can get. So next is zigzag or spiral order. Do not try to see a solution before you try to implement. Okay, try to implement first, then only go for solution from the internet. Okay, next is vertical order. By the way, do you understand what is zigzag or spiral? Do you understand this thing? What is
No
zigzag?
problem.
Okay, so in this tree, zigzag would be 1, 2, 3, 7, 6, 5, 4, 13, 11, 12. Okay? Now you understand what is zigzag? This is zigzag. This is the order we want, final order.
Okay, spiral also means the same.
What? No, hi, spiral also same. Zigzag is same thing. Next is vertical order. Vertical order is I want 13 first. This is the leftmost vertex. Vertical. Then all in the second vertical level, and all in this vertical level, and all in this vertical level. So the order will be 13, 4, 2, this, and then 5, 11, and then 1, 6, 17, 12, whatever. So root is at suppose the root element is at vertical order number 10. Suppose root is at vertical number 10. Then the leftmost vertical is the leftmost side. After that, everything on the just one vertical right beside that. So I want that order. Let me just try to give you the output of this. What will be the vertical order of this? So vertical order of this tree which we have drawn here is, but leftmost is 13, left and vertical, and then okay, noise coming, lot of noise coming, people. So just a minute. We have this vertical, leftmost vertical is 13, and then we have 4 in one vertical. Do we have 11 same vertical or different vertical? Let's see. And 2 is in another vertical. 2 to go right is 5. 2 and 11 is same vertical. 5 and 1 is same vertical. 3 and 6 also same vertical. By the way, 6 also is in same vertical. Doesn't look like so clear from here, but one, 5 and 6 is in same vertical. It looks like same as in order. Correct me if I'm wrong. Santosh? Santosh? You're talking about vertical order, Santosh? Okay. So you're saying that this looks to you as same as in order? No, it's not in order. So in order would be 13. Okay, I'll have to clear things first. So first let me print what this vertical order is. So vertical order is 13, and then 4, and then 2 and 11, and then 1 and 5 and 6, and after that like that only. So this is vertical order. So then it will be 3 and 12, and then it will be 7. So for each vertical we are all in that vertical. This is not same as in order. In order would be 13, 4, 2, 5, no, 13, 4, 2, 13, 4, 2, 11, 5, 12, 1, 3, 6, 7. That will be in order. The complete different. In order, complete different, Santosh. So this is the order you want in vertical order. So these are 3 assignments: reverse level order, zigzag, and vertical. Can you do this? Any confusion? What is this?
Okay, Praveen, will do.
Yeah. So these are 3 questions we should be, after doing so many of traversals, any question on traversal you should be easily able to solve. If you have understood all the traversals, all the pre, post, in order, reverse order, level order, you should be able to analyze, okay, if you use stack, if you use queue, what will be more important? Mostly it's about using queues and stacks only, sometimes not using anything. But with all these storage, you can solve all the traversals. Okay?
Okay.
Okay. Okay, then any question you want to ask? Next question, we'll talk about dynamic programming. We have done a lot of data structure. I want to cover some algorithm. We'll come back to data structure again, but we'll do dynamic programming. Okay. Any question? No?
No problem.
No, Praveen.
Okay then. I'll stop. And people, don't forget to like you will only remind what is the assignment. I'll paste it into the chat as well. Okay then. I pasted into the chat. Okay, it's not going here. Anyways, so bye bye everyone. Bye. Thanks.
Okay.
Ending the class. Bye.
Okay.